the graph, the bottom would be zero throttle or zero motor output. The top of the graph would represent 100% throttle or 100% motor output. So what happens is, right in the middle, right where the V dips down, the bottom of the V there, that is the mid-stick position. So that you can see that, now that would be right about at the 80% mark, about where that V dips down at the very, the lowest point there. That would be roughly the 80% position. As you go down stick, as you're getting more pitch in the negative direction, well, your throttle needs to increase to make up for that pitch, because more pitch adds more drag. So your throttle comes back up, going up to 100%. Okay, starting from mid-stick point again, if we go over to the right, or the throttle stick going in the up position, once again, more positive pitch, you need more throttle. And incidentally, guys, this is what, if you have like a computer radio, computerized transmitter for your helicopters, you will actually see these graphs on the LCD display of your computer transmitter or radio. And you will be able to set up pitch and throttle curves however you like. Say if you're using the DX6i Spectrum radio or the DX7 or similar radios. So that's the throttle curve. Now notice off to the left, or excuse me, off to the right, I've put a picture. There's a picture of the transmitter. That knob, I'll just show you here real quick. Okay, this is the knob we're talking about right here that's on the top of your transmitter, right there. All right, back to our graph. Notice that the knob is turned all the way to the left. Now in the idle up mode, the switch on the graph here, I know it doesn't show it in idle up mode, but just pretend that it is. You can see that the knob is turned all the way to the left. Now what that means in idle up mode is that when you're at the mid stick point, which is what the red arrow is pointing to, when you're at the mid stick point, that means that wherever that knob is turned, that controls how much throttle output or how much motor output is going to be at that point. So it's turned all the way to the left, so that's going to be minimum throttle. And I don't know the exact numbers, maybe it's somewhere around 70 or 80% throttle. But that knob, the important thing to get out of this is that that knob is what controls how much throttle output there is at mid-stick, which also would translate to RPMs naturally. Let me show you the opposite of that, another graph here. Now in this graph it's the same thing, only the knob, you'll notice, is turned all the way to the right. So now we have essentially what's called a flat throttle curve. I know that's something of an oxymoron, how can it be flat if it's a curve, but yet it's still referred to as that. We have a flat throttle curve. That means that whether you're at mid-stick or full negative pitch or full positive pitch, your output from your motor is the same. And once again, I'm not sure of the exact numbers. I do believe when you have it turned all the way to the right, that you are at 100% or very close to 100% output, even at mid-stick. So that's pretty much it, guys. You know, it's pretty simple to understand. Like I said, ultimately, if you pursue this sport further and you get a computerized transmitter radio, these graphs will actually you'll be able to program them on the LCD to exactly how you want them to be for whatever helicopter you're flying, and that includes the Blade SR. The Blade SR can be bound to any type of DSM-2 spectrum transmitter, such as the DX6i, DX7, or the there's a 12X and so forth. That's like a $1,500 radio. You wouldn't need that for this exactly, but they do exist. They are out there. So, okay, so just one last quick thing here. The Blade SR is, of course, pitched as a beginner's CP or collective pitch helicopter, complete with idle up stunt mode, and that's how it's pitched, and I've just shown you how that all works. And to confirm that that is true and that it is a true CP helicopter capable of doing the things to an extent that its bigger cousins can do, this is Mr. T-Rex 600. And just to show you, I've moved Mr. T-Rex's blade out. Right now I have it bound to a DX6i Spectrum transmitter. We're at mid-stick. Watch the blade tip. We're in the idle up mode or the stunt mode. If you watch, as I move it down, negative pitch, mid-stick, zero pitch, up stick, positive pitch. Negative pitch, positive pitch. That's your idle up or stunt mode on the T-Rex 600. So there you have it, guys. Your idle up stunt mode and the representational graphs to show how that works, and also the real life demonstration of how that works with the helicopter itself here. So once again, this is Rob from the Helicopter Skunk Works. Hope you enjoyed this video. Happy flying and take care.